Yes, that is true. Okay, can Zoom hear me? That is my bad. Is it are we good now? Oh, yeah. Okay, cool. Yeah, sorry about that. I hope I'm also can you also see me on the thing? Yeah. Okay, cool. Um, okay, well, yeah, basically just saying A6 deadline's longer than it normally is in 2 weeks instead of 1 week. So you can focus on the hack challenge. Um, let's see. So for next week, since this is like the last week of official sort of course material, um, since the last week. Next week will just be like bonus lectures. So you'll get attendance, like bonus points for attending, but you won't be like penalized if you don't show up. So +1 point to your final grade for each bonus lecture you come to if you choose to. Nothing too totally big, but small incentive. Currently, we're planning to have at least one lecture on like the Android job search, which sounds pretty appetizing. Hopefully, that incentivizes people to come. Basically, like internship searches, like how like the job market is, things like that. And uh, I've said it a few times, but Android job market is really, really good. So hopefully we can give some tips, and maybe that would be appealing to some of you who are looking to do this more, or like dive into Android more later in your careers. So show up to that if you'd like. That's probably going to be Monday, but we'll like send an announcement about that. And finally, for anything like Hack Challenge related, you'll want to join the ed discussion for that. We won't be going over the announcements here anymore unless it's something like grading wise or something like that that comes up, or it's something that they tell us to show in lecture. Other than that, you'll want to check like the ed. There's a link there if you have, or if you're following along with the slides, to make sure that you're in that ed discussion. And yeah, all of like the relevant Hack Challenge announcements will occur there from now on. Okay, so let's see, getting into today's material. So we're primarily diving into like the model layer of MVVM, which is like the final piece of the picture, which will then encompass like networking. And in order to preface that, we'll go over coroutines and finally how to actually do networking with coroutines and stuff like that. So as a bit of a recap for how to structure our model layer in MVVM, for a bit of a recap, the model layer in MVVM provides like really easy, simple ways for view models to make networking requests and get networking results. Basically, like calling your backend so that your view model doesn't have to care about, okay, what like URL do I have to hit, anything like that. It'll just call like a nice function, be like, okay, I'm going to make this request. The model layer will do all that complicated business and then just give the result to the view model. Then of course, as just like a recap, the view model then can update the view, the UI, whenever the networking has completed. Okay, and altogether, I mean, this forms like a complete picture of how to build like an entire working Android app that you can really like do anything with. Of course, this course goes over like really simple stuff, like how to do the sort of basics, but with this overall structure, you can really build like anything, especially since now with backend networking requests, you open the door to doing a lot more like real actual business logic. Okay, quick note about Hilt. So in your assignments so far, you've probably seen stuff like this, like these weird annotations above your classes at Hilt view model, at inject constructor, at singleton. You might be wondering what this all means, and of course, we've been like blowing this off until now, so we can quickly go over what Hilt is. So Hilt is a library that handles what's known as like dependency injection, which is very directly related to like MVVM, such that it'll like make referencing your objects such as view models, stuff like that, a lot easier in MVVM. We've already set it up for you in assignment release codes, and I think we had that like one demo to like set up Hilt or whatever. Again, you don't really need to know how Hilt works, but you definitely need to know how to use it in order to hook up your MV and VM like throughout your app. So the overall idea with Hilt is that like whenever you have an object that needs to reference something else, so in this case, like a view model that needs to reference some model layer repository that's doing like networking calls, I guess. Uh, photo rate, I think this is for A5. You use this thing called an at inject constructor. And like the inject basically is an annotation that says, okay, Hilt, if I ever reference any Hilt objects in this constructor, Hilt will automatically inject them and like provide a reference for them for me automatically so that I don't have to do it myself. And so For example, here, I think this is again your A5 code. There's like a photo rating repository that does some like mock networking requests for like rating a photo. And in order to get a reference to that, I don't have to care about when in the life cycle that's made. I don't have to make it myself. All I have to do is just like reference it as like, oh, I want it in this class by putting it in this constructor. It's literally just like I don't even have to provide a value for this manually myself because I labeled the constructor as at inject, this will automatically be referenceable in my class. And like I, again, don't have to pass it in manually. And so with this, you can take your repositories, aka like your model layer stuff, and inject them into view models or into like other repositories if you have like really complex repositories and stuff like that. So this makes it super easy to like reference networking calls or reference classes that'll do networking calls for you. So like if you have a repository that'll do networking calls for you, you just inject it into your view model and you can immediately start doing your networking. Okay. Any questions about any of that? Like HILT, what that does, MVVM? Any questions? Anything online? Quick question. Oh, no. Cool. If we have no questions, we'll move on to coroutines. So, quick sort of like idea of what coroutines are, and then we'll like go into some like code of how to use coroutines. You've probably seen like a line of code like this lying around your assignment code. And again, we've kind of been blowing it off for a while as to what this does. This is, let's see. So this line, for example, view model scope dot launch is the launch of a coroutine. In this case, view model scope is a coroutine that you can reference only in view models, which is like the best practice to use whenever you want to launch a coroutine in a view model. You want to use view model scope. But yeah, let's find out what this means. So the general idea is like multi-threading of coroutines is to like implement multi-threading in Kotlin. So this is just an overview of multi-threading, which you've probably like seen from 2110 or whatever. Multi-threading, the process of like running multiple sequences of code at the same time. And this is really important for networking code because sometimes it takes like a really long time to load stuff off of the internet or like from the internet. And even if it doesn't take that long, it'll still often take like a couple of like maybe half a second or something. And uh, for example, if we were loading something from the internet, even for like half a second, we wouldn't want our entire app to freeze, not be able to respond, not be able to see anything for that entire half second when something is loading. So we'll want to run it to primarily like, or the idea is on another thread so that it doesn't freeze the app while it's loading. Uh, so in Kotlin, there's a very unique way of managing multi-threading or like asynchronous code that's very different from Java or Python, and thankfully like so much easier than Java, Python, etc. Which is why this is why I think it's like really or why Kotlin's really nice for Android development and much preferred over Java these days. It's called coroutines, and they are like probably implemented really complicatedly. Like that's like the first thing that comes up when you search up coroutine like explanation on Google, and like I don't know what's going on there. But fortunately, I don't know what's going on there, and you don't have to either, because coroutines, again, you don't have to know how they work. You just have to know how to use them, and they're extremely easy to use. So the idea is whenever you need to run like any line of code or any like block of code on another thread, like that line of or that block of code synchronously on another thread, you'll just launch it on a coroutine. And in terms of like thread safety, blah blah blah, all that other stuff you've learned in 2110 of like, oh, you have to be careful of this or this. You actually don't have to care about it because Kotlin handled all the rest. This is a lot easier than like Java for sure because you don't have to worry about like locks, synchronized race conditions, any of that stuff. Yeah, I don't like doing that either. Nobody does. And so Kotlin will handle all of that for you. Okay, any questions about that? And if not, that was just a sort of basic overview. And if not, we will jump into, I guess like a little bit more clarification before we go into code. I thought we did code next. Yeah, if no questions, then we can go on to more of like how to do this in code specifically. So here is like a keyword called suspend. This is a like a I'm not really sure how to describe it. It's a keyword that you'll put before a function to declare if it's like asynchronous or not. So in general, there are like two types of lines of code or like two callable functions in Kotlin. either non-suspending, aka just like your regular lines of code, you can just call them whenever, or you're suspending lines of code. And the idea with the suspending line of code is that if you call it on a particular thread or like coroutine, whatever you want to call it, it may freeze execution of that thread for a little while before it finishes executing. And so here's an example of one of the A5 suspend funds, aka like asynchronous calls that will, or not necessarily asynchronous calls, just one of the calls that might take a while to run before it terminates, before it finishes terminating. Um, this is called get image from ID, and it's supposed to mock like backends that like, oh, I have an ID and I want to get what image this is associated with. In order to mimic that, we just make this wait for like 500 milliseconds before returning it. That's like our mock networking. But the idea is nonetheless that even if this was like a real networking call, it would like do whatever networking stuff, and that might take a little while. And therefore, this whole function might sort of freeze at certain points, like take a while for certain lines of code to finish executing before the entire function is done and can return. And so normally, if you call a like suspending line of code or like a suspend function in just like a normal uh, block of code, that would throw like a compiler error. But if you declare a function as a suspend fun, you can essentially declare that you'll know that lines of code within that function might take a while to might take a while to complete, and therefore the entire function might take a while to complete. You could imagine that because again, there was like those two lines of code, either non-suspending or suspending. If I didn't say that this was like a suspend fun, get image from ID, then the like the coder using get image from ID wouldn't know that it could freeze the thread or whatever. So this is just like a sort of compilation level way of Kotlin saying like, okay, let's really make sure we know when we're using synchronous or asynchronous code. And so I guess the idea is by declaring a function as a suspend function, you tell Kotlin that I know this function will have asynchronous code or like code that will take a while to complete. Don't worry. Therefore, like because I'm saying that I know that this function could have asynchronous code, I can just call a bunch of suspend funds like back to back to back, and there will be like no compile level issues. The idea is though, and pretend that these are like a bunch of suspend funds that like are provided by like networking libraries or like my repository layer, blah, 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 blah. At some point, you'll have to run this on like your regular code, like in your view model, for example. So if my view model like or if my user like presses a button and that triggers something in my view model, eventually you'll have to call one of these suspend functions to like actually do some networking stuff. And this is where you'll launch a coroutine. And so the actual body of the coroutine will take time to execute, may freeze on certain lines because of the suspend funds, but because you launched it on a coroutine, it'll sort of run on the background while the rest of your app runs just like it normally would. Okay, and so there are a few ways in code to launch coroutines. If you're in the view model, you want to use this view model scope. In any case, it'll be some sort of like coroutine scope dot launch. So in this case, for a view model, you use view model scope. Anywhere else that you're doing like networking requests, so this could be in like another repository. You could use this like syntax here. It doesn't really, you don't have to worry about really what this does, but coroutine scope, and then it takes in like a purpose for it, which in this case is like IO, because I guess it's like networking. There's also like dispatchers.main, which I think runs it on the main thread, which is like sus. You don't want to do that because that could like freeze your app. So you'll run it on like IO. Yeah, whatever. So you can also launch like you can launch coroutines like within another coroutine. This is like a pretty rare use case where like one example where you might want to use this is if you have like 5 different networking requests you want to call at the same time and then wait for them all to complete before going forward just to speed things up instead of like calling one thing, waiting, calling one thing, waiting, calling one thing, waiting. If you want to like run them all at the same time and then like go when they're all done, that's like a specific use case. This is not something you'll be very likely to run into, so we'll not, or we didn't provide any code here. But in your UI, you might see some suspend funds such as like animate scroll to item, for example. is something you can call in like a lazy column that will like take a little second to scroll all the way to the top, and then the function terminates. Uh, that's one example of something that is like a suspend fun in your UI. So this is like in a composable scope where you can use this line remember coroutine scope in order to just get another coroutine scope in your UI. And in any case, once you have that coroutine scope, you can just call .launch to run the body of that code asynchronously. I think the general idea, I didn't actually write this in the slides, but within the block of code, all of that code like runs technically synchronously. And so each line of code within that block will wait for the line before it to finish, before going on to the next and the next and the next. It's just that that block will sort of run in the background instead, such that it doesn't freeze your other like functions happening in the app. And yeah, that's it. So there's like no more hassle needed to do networking or like asynchronous code or like multi-threading at all in Kotlin. You basically just launch a coroutine scope. Yeah, and then like whatever body you have there will just do asynchronous stuff, which is a great reason to love Android over Swift iOS, because in iOS you have to like do all that manually, which sucks. Okay, any questions about that stuff? Launching coroutines in code. Okay, if not, we can get into a quick code example of this stuff, which is not too much of actual like networking, but kind of just how to practically do like networking in like a code example, or more of like how to manage the flow of networking in a code example. So this is lecture 6 demo. Again, if you're following along, you should run git fetch, git pull in order to get like the most recent version of this, because I changed it quite a bit for like an hour ago. Yeah, I had some time at home before today. So basically today we'll be going over this like very, very simple app where it will actually hit a real endpoint to allow you to search for like a particular cat breed. So the idea is you can like type your cat name here, or actually my real phone here. I can type in like hopefully like Maine Coon or whatever, and it'll pop up here after loading. It's not implemented yet, so it'll just say loading forever. But the overall idea is that my view model, whenever I hit the submit button, you can't really see that because this is blocking it. Whenever I hit submit, this function will call here on submit. And so the reason you can see it's like loading and like the buttons grayed out is just because of this. I turned my UI state to say I am loading. I erased the query, and like there's no image data yet. So I'll just put that as null, but there's actually no networking happening yet. So in order to do some networking, I will introduce you to a few files that I have lying around. So first, this is like a fake networking repository, because we'll go over how to do actual networking in the next part of lecture. But for now, we'll just have like our last example of like a mock networking that has this like fake version of the networking, fake version of the endpoint that we'll be hitting in a second, where you just basically give it the name of the cat that you want to search for, and then it'll like return data about that cat. The idea, though, in order to test that our app is like handling networking well, you can see here, is that it either throws an error or like actually correctly returns the cat. So there's a 50% chance that it'll just like fail and say like, oh, we're down, check back later. And then a 50% otherwise chance that it'll actually return the real cat. And this is really important because networking requests fail like all the time for like almost no reason. Maybe your user just walks away from their router or like is connecting to a different network. Like these networking calls fail like a lot of the time. And so you really have to make sure to error handle correctly. Otherwise your app just crashes. And so if there's nothing else that you'll error handle correctly, maybe like null pointer exceptions, blah, 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 because Kotlin's usually pretty good at that. Make sure to really make sure to handle your errors well when it comes to networking calls. Okay, so in any case, let me turn off my AI autocomplete and then start coding. So in any case, we can start using this like fake networking call to like start doing some networking-ish. So we'll say like, oh, well, first, we can use this inject constructor to obtain a reference to this singleton here. So this is an example of like a model layer networking repository where a view model can reference fake cat networking repository to like do networking stuff. So because I've annotated it with singleton, I can just use hilt to like inject this like without any hassle. So just say private val fake cat networking repository, oops, just like that. And that's literally all I have to do. And now I can reference this file to do like all of the calls, which is like, again, why hilt is really nice. I don't have to actually call that constructor anywhere or like care about when that object fake cat networking repository is made. I literally just like reference it as if I would create it, and then hilt does that all for me. So I can do dot get cats, and the query that the user typed in I saved here. So that would be here. And you can see here that because I put get cats as a suspend fun and on the submit is not a suspend fun, it'll give me an error. So like the suspend fun should only be called from a coroutine or other suspend function, which is the like whole like asynchronous paradigm I was talking about before. So in this case, we want to run a coroutine because we actually want to be able to use on submit to just like call it in our UI whenever the submit is pressed. So to sort of indicate that we are going to be doing like asynchronous networking stuff, we will launch a coroutine here with viewModel scope.launch. And so now that line of code will not give us an error because it's in the coroutine scope. And if we roll over this, we'll see that this returns a list of cat, which the API that we happen to be hitting later just uses like a list of cats, so don't really worry about why it's a list. It'll basically just return like one cat object or just fail. So we'll just say cats. And for now, we're not going to bother error handling. Let's just say that, so now, let's see, I guess now, for now, I can just say that the API later on might not return like a cat if I just type in like a query that doesn't make any sense. So for that example, let's say that the cats list doesn't return anything. In that case, I can indicate that to the user by saying something like, let's see, I'm no longer loading, but I didn't load any cache, something like that. And then a way that you can sort of end the coroutine is with return at launch. This basically means like it'll return up to this launch instead of like the on submit, meaning that it basically just stops the coroutine. But let's say it continues past that if statement and doesn't end, therefore the cat must not be empty. So cats is not empty here. And so we can just get like the first cat, for example. That's all we'll care about. So if we look at the cat object that we have now, we can see that there's a name and an image link. This is often what you'll see networking requests return. It won't actually return like the real image data, like the sort of image array. It'll just usually return like a URL, which you'll have to load later. So this, I'll talk about this in a second with the lecture, but I also have this repository here that'll load an image from the URL. By the way, this is stuff that you'll be able to like copy for yourself to use like in the hack challenge if you want like stuff like this. But if you want to look at the like details of how this is implemented, you can, but this is not something we'll like go into now. We can reference this coil repository to, and this is already injected, which is why we can reference it to like load the image. So let's say image bitmap equals coil repository dot load cat dot image link. And so now we actually have the image data as well as like the cat data. So we can finally indicate that to the user and say, let's see, yeah, so loading is false, the cat is the cat, and I think there's a separate thing for the image data. Yeah, image data equals image bitmap. And I've already implemented the UI to like listen to these things such that if I change image data, that'll change like the image that pops up here. If I change like the cat and loading, blah, 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 to like change the text from loading to the cat's name, stuff like that. So if you're wondering why that automatically updates, it's because I already implemented these screens. So that is not quite finished, but let's see what happens if we run this. So if you're curious, this is basically like the first, second, and fourth. We did not error handle yet. And let's see what happens if we don't error handle. This will take a little while to build. But the idea is that if we don't error handle and the function happens to give us some sort of error, because we're not handling it with any like try catch stuff, this will just like crash the app. So let's see what happens. There's a 50% chance that it does because that's how I implemented it, and it happened to crash that time. If we take a look at our error, we can see that error, right? Or I think that is the wrong one. Here, yeah. Cat service is down, please try again later. And let's say we were running an app and our backend happened to be down. We wouldn't want that to just crash the app, right? We'd want to show something nice to the user, be like, oh, try again later, maybe provide like a retry button, something like that. We wouldn't want our app to just crash because the internet was down, right? And so this is where our like error handling can come in. So this is not something we explicitly showed in lecture, but hopefully with this demo, you can carry this on to like your general networking knowledge or just like Kotlin knowledge. This works very similarly to something like Java, where you can wrap it in a try and catch statement. I usually just say this is a regular exception. This maybe there's a better way to do this, but I just catch all types of exceptions and it's usually fine. Good practice is to log it so that if this exception happens, you as like a debugger, developer can like look into your console and see why this is still happening. So something like cat view model, error fetching cats, and then you can like provide E here to print out the entire stack trace if you'd like. Just a little tip. And then let's say, okay, well, if it failed loading, let's just make sure to indicate, oops. Let's actually like change the screen to make it so that, yeah, we didn't load anything, or like our loading's done. We didn't return anything. Our catch is nothing. And let's say that our image didn't return anything. If I wanted to error handle even better, I think this is something I'll add very quickly. Let's just say like to our UI state that like, oh, I ran into an error. Let's say that's false. But suppose that like, yeah, we ran into an error. Let's add like a new clause here that our title should say if we are experiencing an error, that our title will say like error, please try again. Something like that. And once we run into this error here, we'll say, yes, we ran into an error because we just caught this exception. And otherwise, once we start this function, we'll just assume that no error has happened yet. Okay, so with that, that's like one example of how to error handle with this like try catch statement using like a new error field that we just added. That's not something that's reflected in the solution branch, but obviously this is like more of a design thing. Like how do you want to handle errors to your user? This is just one way to do it. So the cat that I hard coded is called Abyssian. Okay, so therefore, if anything pops up, it'll just be that cat. But here we can see that the error was met. It'll say error, please try again instead of crashing the app, right? Because of this catch statement that we have. Hopefully this actually pops up at some point because this is a coin flip every time I hit this. And yeah, there we go. Let's say that after a few tries, the networking request actually works and our cat is returned. Now, we didn't do any real networking. This is still just that fake repository that's like returning true half of the time or returning like the actual cat half of the time. But this is how to implement like your view model correctly to make sure that networking happens correctly in any case. So I think one final note I'll say is that like the fact that we're able to implement like the UI and the view model completely separately, even though we have like literally, I guess the only thing we have actually doing networking is this coil repository, but nonetheless, we can implement like almost all of our networking code or like our app's logic without even writing a single networking line of code because of MVVM. Due to the fact that MVVM allows you to build your UI, build all of your like app logic, and then finally build your actual networking requests all separately. And so you could have like 3 developers working on them separately all at once without having to worry about like how the app completely all comes together, if that makes sense. It's sort of like a separation of concerns, abstraction 2110 idea. But that's sort of all the code we have for setting up like the view model to do networking correctly. And then later in this lecture, we'll go into like how to actually do networking stuff. So any questions with anything that just happened in here or online? Oh yeah, question.
Change the cat to like the error again.
Oh, okay, yeah. Good question. So the question was, how do I make it so, let's see if I can get this thing to show up again. Yeah, how did I get the title to say error, please try again? In short, I have implemented a lot of logic already with the screen to make it so that the view model has complete control over what title is being displayed there. So you can see here that I have this derived field title text that is just using other values of the UI state. And so, for example, before it was just this code here, or this code here. So if it was loading, it would say loading dot dot dot. If it was not loading and we had like a cat, it would actually display the cat's name, which is why it would say like Abyssinian or whatever before. And if I just opened the app, it would say search for a cat, which is what we saw before. If I go into the text here, you can see that this is actually being referenced in my code, in like my screen code, which is how the title is changing. This is basically stuff that I already implemented before, like demoing this to you guys. But the idea is I can just change this field value title text. And then because I've implemented it already, the screen title will change accordingly. So if I now add this new field saying that there's an error and say that, oh, yeah, if there's an error, return error, please try again, that'll just do that and show that as the title. Does that make sense? Cool. Awesome. Okay. Any other questions? Okay, cool. We'll get back into the code in a little bit, but first we'll talk about how to write actual networking code. My music was playing at 6 volume there. Okay. Okay, the last part is how to write actual networking code, since we've just been giving you mock networking code over and over and over again. So how do you write actual networking code? I will leverage a library called Retrofit for that. So intro to how to use backend as an Android developer. So backend responses backends generally operate, backend like servers and whatnot, generally operate by providing you with a set of endpoints. There are some backend structures that like don't use endpoints and use like query structures or something like that. I think I'm pretty sure it's very safe to assume that your hack challenge group will use this like endpoint format where each endpoint corresponds to one URL your app can ping and it'll give an expected response. So on our app resell, we have these two endpoints here that are like auth login to log into the app or like tell the backend that you logged into the app and log out to tell the backend that you logged out, stuff like that. And so whenever you do what's called like hitting an endpoint, basically like initiating a networking request, your app will wait for the response back from the backend server before it can complete like that line of code. And so the response that you get back is often in the form of JSON, which is just like a string format for data, which happens to be in like a tree structure, but can be referenced or can be pretty much just represented as like one big string of data. And so this is the API that we'll aim to hit. This is like publicly available, like some company, I don't really know what their prerogative is. I think they're like you can technically subscribe to them to like get more APIs or whatever. But this is just like a company that's out there called API Ninjas, and they are giving us this cat API, which allows us to hit this endpoint there, api.apininjas.com v1 cats, to get this JSON, or it's like a list of these objects. You can see here that this JSON represents like one cat. So this is the Abyssinian that we were seeing before, and it has all this other information about what a cat, or like what could describe a cat. And so writing our own networking code to parse all that data would be really annoying. To like get that networking string like change it into a data class to all that stuff would like really suck. So we have a library that does it for us, Retrofit. It's called Retrofit. And so with Retrofit, we can hit endpoints, convert them into our custom classes with really no effort at all. And so retrofit is like a third-party library, meaning that you'll have to add like Gradle dependencies to your build.gradle file in order to use retrofit. I think these are the three things you'll need to add. Um, OK HTTP, which is like how to actually do networking requests, retrofit, which implements it all for you, and JSON, which is like handling and converting JSON objects for you. So here we'll go over like a brief idea of how to implement and use retrofit. So it works in a few layers to define your endpoints, like write what URL should be hitting and whatnot, convert them into Kotlin objects that you can use, and then to like actually hit your endpoints, like actually make the requests. These all exist in the model layer, but you can imagine that like it exists at the kind of very top of the model layer, and there might be other repositories that reference like these networking capabilities. And so, yeah, other things in the model layer might actually use retrofit to make the networking calls themselves if you have like a very complex model layer. And so let's see, to use retrofit, this is like the three parts I was saying before. You define the API with like an interface. We'll get into how that works. Make a retrofit instance class, which you can largely just like copy from our slides. And then finally, you inject this into any repositories or even view models where you might need it. And so the first layer is like this interface. So for each URL or like each unique endpoint that you're hitting, you'll need to make an interface representation like for that URL. And then within that interface, you'll specify all of the endpoints that happen for that URL. And so you can write each endpoint that you're hitting in this interface and then define the response that you expect to get from that endpoint. And so this is the like function that will eventually write to hit that API Ninja's catch call. But you can see here that like it's specifying that we want to hit the cat's URL and then specifying like the other pieces of data that we have to get or have to give to it. And then we also define like this cat class that we can see we're getting as a return type here, list of cat. We just sort of define all like the information that we need to get. I may or may not tell or like should be telling you this, but ChatGPT is really good at turning JSON into data classes. So like just copy paste the entire JSON, tell it to convert to a Kotlin data class. I'll literally like demo doing that. And then it just does it all for you. So you don't have to write all this because who wants to do that? Yeah, I mean, it's just using tools that you have at your disposal intelligently, right? I think it's a good thing to share. Next, the retrofit instance is like kind of just set up for like parameters, adding stuff like that to your like networking requests. So you can like specify the URL, stuff like that. I mean, this is not stuff you'll likely have to toy around with very much, and so you can mostly just like copy this. But this is also the model layer thing that your other objects will use to make networking requests. And then finally, you take that retrofit instance, inject into somewhere, and then you can actually use it within like your view model. But this can be injected into like any model that you want. So this retrofit instance is what you'll use to actually make those networking requests. And then after that, you can actually make real requests to the internet. As a quick aside, you might be wondering what that coil repository was before. This is a library that allows you to load image URLs. And it also has like UI components that if you give that UI component just a URL, it'll like automatically load it in for you. So you don't have to like write manual code to load it from the URL and then push it down to your UI. It'll just like load for you. And then, yeah, you saw from my coil repository before that you can load images from URL for like more granular control, which is like useful sometimes. It looks better too. And as a quick aside for permissions, you'll see this in the lecture demo code in Android manifest.xml. This is just like a config file, but if you want to do actual networking requests, you have to add this one line of code for like internet access permissions. This is not something that you actually have to request from your user, like permissions. Like you would have to request actual notification permission, stuff like that. It'll just automatically grant it to you. I don't know why it doesn't just do it automatically, but you'll have to add this. Okay, any questions on retrofit stuff? It's okay if it's not clear because we'll just, like, it's mostly just learning the motions of how to use the library. And then after that, You just use it like you have learned, stuff like that. But yeah, any questions before launching into demo? Okay, cool. In that case, weird. I don't know why it's saying a unread message. Seems okay. Okay, so now let's go ahead and actually implement some networking. So we can see here that I have like this retrofit package folder here. And the retrofit instance is like mostly implemented. You can see here that I have this URL. Oh, and before going into that, actually, I should pull up the page here for this if Zoom can get out of the way. This is the page that API Ninjas gives us to learn more about the API. This is like documentation, I guess, and hopefully your backend members will give you this. And if not, you can just ask them for like this kind of information. But they're giving you like the URL to hit. This is weird. They're giving you like the URL you should hit, the parameters that you have to pass to this endpoint, and the response that you expect to get. So this is basically like specifying how to use this endpoint. Gives you everything you need to know, like what data do I have to give? What do I get back? Where, like what URL do I have to hit, etc. And you can see here that this website gives a lot more of like a bunch of different endpoints. There's stuff about like finance, blah, blah, that uh, boring, but you might find actually more useful for making like apps that make money, but whatever, we're just making a cat app right now. So, to use retrofit, you'll have to, gosh, I'm just gonna take this thing off. In order to use retrofit, you'll have to use or to create like an interface. The idea with the interface is that you won't actually implement anything yourself of like, oh, make the networking request, do HTTP stuff. Retrofit does that all for you. You just have to kind of indicate what you want the function to do, which is why it's like an interface, and then retrofit implements it for you. So following the to-do here, which is just information I got from the website, this is a GET request, so I'll use the GET annotation. And it was at blah, 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 /cats. So I'll put the endpoint as like hitting cats. You can see here that the retrofit instance has the rest of the URL ending in a slash. And so it'll just basically take cats and like put it on the very end of that, if that makes sense. And then, so that's how to say it's a GET request. There's also like a POST request, which is like posting data that modifies something on the back end versus GET, you just get some information. And so we'll want to say it's a suspend fund because it might take some time to terminate. And let's say let's call it get cats. The name of this is just for your own purposes, what you want to call it for your Kotlin code. But it has a name query parameter. So there's a lot of annotations you use in retrofit to like specify these as certain things. So this is a query. And again, this is mostly just stuff you'll ask like your backend member, like, oh, what type is this? How do I use this stuff like that? It's called name. And it's a string. Oops, this is just a argument. It's query string. Yeah, it's a query, which is always going to be a string. It has this header that is called X API key, which is like authorization to know like who is using their API, which I'll actually like expose to in a second, which is not good practice. But the idea is that I have my own API key, and if you guys sign up, which is something you'll do in A6, you will all have your own API keys. So theoretically, like if I was paying for this, you could just use my money, but this is like a free plan, so you're not getting anything from me exposing my API key. But yeah, you shouldn't just paste this in because this is how like a backend would know that this is you calling this and not somebody else. So don't expose this like I am. But I'm doing this for educational purposes. So that's all that this endpoint needs. And I guess this header is just like what API ninjas would always need you to do to use their API. But finally, we'll need to return a list of cats. And you can see here that there's a lot of information missing right now from the endpoint that I get here. Gosh, can the Zoom thing please get out of the way? there's a lot of fields that I'm missing. I will quickly demo how to use ChatGPT to just make a class for you. So let's say I'll give it the JSON and say convert this into a Kotlin data class called catch with backticks to make it a little easier for this. And if you want, something that you'll notice is that some of these have like underscores since that's the naming convention for JSON. You want it in camel case, so you can just like specify that. Make sure to make the fields camel case, but still convert correctly, something like that. What you should hope to see is like this annotation stuff that it uses. Uh, Let me engineer a better prompt. It did not use it. Okay, I'll just say explicitly with serialized name. Basically, this is like a way you can make the like each field like have a different name from what you actually name the field. Otherwise, it would just use length origin. But you can see here, for example, for image underscore link, it'll like say that that's what the JSON is expecting, but we're just going to call it image link instead because that's better naming convention. And then, yeah, like I'll literally just copy and paste this into my app uh, because it's like, who wants to write that all themselves, really? Okay, cool. And so now there's my data class written purely by my own hands, I'm sure. And so, yeah, now we can use all of this data in our app. It'll like fetch it and put it automatically into the class ourselves whenever we call get cats. Okay, and let's see, that should be everything. And notice that we don't have to do any manual stuff about taking that JSON and converting into the cat. That'll just sort of happen automatically by retrofit and like those other libraries that we called. And so, unless I forgot anything, which I guess we'll see if we forgot anything in a second, we can just go ahead and use this. So suppose I wanted to just use this directly in my view model. I could say retrofit instance dot cats API service dot get cats. And this only takes in one parameter, which is the name. Otherwise, the API key I just hard coded in there. And the name is like basically what I've typed in. That's the name that I want to search, like the name of the cat. So that's what I've typed in. Just the query was the same thing as I had before. And so now, because I'm hitting like this actual endpoint, oops, yeah, I had all these things commented out because I knew I'd add it later just to get it to compile. Oh gosh, the Zoom is so annoying. Let's get out of my way. Okay. So now I'm using like this actual interface that's hitting like a real backend in my view model. And so hopefully we can actually search for real cats. So if I search of Maine Coon, promise I didn't hard code this, pops up. Oh, you can't see that. There you go. If I type in Maine Coon, that pops up. What else? Some sort of short hair. American short hair. Oh, adorable. Any other preferred cat breeds? I know Siberian. And pops up. Awesome. What else? Tabby. Oh, that didn't award a search, unfortunately. I probably would want to put there equals yes there, but is there a long hair? I think there is. Oh wow. Very fluffy. Uh Calico. I think it's searching for like breeds. I think that's maybe just like a color. I'm not sure any other breeds that I know of. Anyone on Zoom want me to search anything to celebrate us writing a Persian? That's a good one. Or Siamese. Yes, let's also see that. Persian. There we go. Oh, that's the Crumpy cat. Yes. We said Siamese, right? Are they the loud ones? Oh yeah, they're. I like these cats because they look like they have a burnt face. It's like a blowtorch. Not in a cat way, like a creme brulee. Like if you were to toast a marshmallow, I mean, you wouldn't do that to an actual cat, I swear. Ragdoll, nice.
Is this all from the library?
Yeah, exactly. Yeah. This is all provided from that API. This is all data that they have on that backend. So yeah, I didn't hard code this. I don't have all these images. It's hitting a real API and it's showing, which is awesome. Which is hopefully what you'll be able to do once you build like actual app for Hack Challenge or whatnot. But yeah, if nobody nobody else wants to search up more images of cats, that's all we have for today. So unless we have any questions, if anybody does have any questions, you can ask now. But yeah, most of that is just like kind of referencing example code to see how to use the library. But yeah, any questions? Okay, awesome. If no questions, then that's all we have for today. And that's the final like real lecture. So thanks very much for coming. Here's the coveted attendance form. But yeah, that's all we have for today. And hopefully with this info, you can go forth and make real apps, since that's concluding MVVM. Obviously, though, we'll still have a demo with getting to know like, or getting to get some hands-on experience with like networking stuff like that Wednesday. So make sure to still come for that. But yeah, otherwise, thanks very much for coming. That's all we have.